this kind of example that you use, it is very likely that they can release it. But whenever one wants to talk about the intruder protection, about the security, the privacy, and the other things from telecommunication industry, most times, so in they are very reluctant in releasing those messages on the name of the security, privacy of the subscribers. So in that case, I won't want to do security inclined work. So in that case, how can the researcher do it that those data sets are not being released by the telecommunication industry? I won't want to have a well-grounded result research in that area.
Okay, thank you very much. So, yeah, this is the challenge in these are challenges in the area of data collection. And because, it's business world, so you always have the business entities being very careful about where will they release their data set. It's not only in telecom. In fact, telecom, when it has to do with security, it's another issue entirely. Even in oil and gas industry. So where they need machine learning a lot to make a lot of decisions so that they don't waste their efforts in implementing, in digging well that will not work, that will not produce oil and the like. But still, they are very reluctant sometimes to release their data set. So, but I want to believe with appropriate rapprochement, get closer to them. You have to have somebody, sometimes they ask someone to sign an undertaking that you are not going to share that data with anybody. For example, in our experience with oil and gas, sometimes they ask you, hey, you have to sign an undertaking. Even people who use the data for PhD work, they will have to sign an undertaking that PhD should not be made available online for 3 years or 4 years, depending on the kind of data set that they have released. Because they are always aware that if people get hold of this data set and they're able to trace it to the company, then they'll be able to know how they are performing, what has been happening to them, and they can take advantage of them in that direction. So they're always very much conscious of this negative implication. But sometimes they say, okay, we release this data to you, but it should be done anonymously. Anonymous means on no account should you mention the name of the company that released the data for you, because they're going to take away any information that can reveal them. Sometimes you can suggest this to them. Always let them know that anonymity is very, very important. You have to stress it for them. You see, we are not going to reveal where we got this data because they might not be aware of that. A lot of companies, once you say you need data for artificial intelligence, they think you are going to put them everywhere. Everybody will know the data is from them. You may have to educate them that, we are not going to show the name of the company where we took the data. In fact, anything that can identify your company, we are going to remove it from our data set. So give them that confidence. Hopefully that will let them be reasoning with you and be ready to release their data set. Because it will also help them at the long run. So, but, if somebody don't know the implication of something, it's the easiest thing today is to say, no, we don't release our data. Because they fear a lot of consequence. So you have to be able to alleviate their feeling that, no, there's no problem. Everything is going to be fine. So we're going to use it in a way that they cannot trace where the data is coming from. And sometimes they say, okay, don't mention us, don't mention our name, remove this column, anything that can identify them, you can. So you need to talk in this way to convince them. And also you have to go with somebody that have a kind of good relationship with them. Yeah. So, trust is hand. You cannot just go to someone one day and he doesn't know you and they say, hey, you need to trust me. No, people don't build trust like that. So they need somebody that they know very well, that have been their customer for a long time. And that customer will introduce you to them that, no, this person, anything you give to him, whatever you want him to do, is going to abide by the rules and regulations. So this is just an advice on how you can approach this kind of people to be able to release the data set. Because fact is, people are always afraid of releasing data set. But with good communication and explaining the consequence and the advantages they can also gain from releasing the data, and the assurance that the data is secure and the privacy will be ensured, then I believe, inshallah, we will be able to get it through. So I hope I'll be able to shed light on that and it's answer the question.
So I've been beneficiary of the YouTube video, but I am trying to make a prediction of basically mechanical and thermal properties of a fiber reinforced composite. So I have the experimental data. So based on your guidance on the YouTube, I tried to model it on Wika. But after modeling it, I got a very significant R value, like 96% R value. But my MAE and MSE, mean absolute error, was very high. So I want to ask if I can rely on only the R value. For instance, if I'm trying to see if I can try to publish the data, the results. Another thing is on Wika, how can I get the plot of predicted and the actual value?
Okay, how you can get the actual value, predicted?
Yeah, the predicted and actual value, and if I can rely on only the R.
Okay.
On regression prediction.
Thank you very much. You're welcome. So, Samzat, yeah, you can actually, it depends on the area. You have to look at the literature. So what, maybe if you are the first one that is trying to establish machine learning in this area, then you can define what needed to be done. You see?
Okay.
If order, because I've seen people who attended our lecture and they were the first one to think about machine learning in that area. Now they are making a lot of inroad and progress in that area. If you are the first one, then you have to determine what's going to be the yardstick for the performance measure. However, if people have worked in this area before, then you have to follow what they have been doing, because you are going to compare your work with their work. Even if you are not using the same data, at least we have relative comparison and see how your work is doing. In this sense, the minimum is at least R and root mean square error. Based on my experience and my recommendation, the minimum is you have to choose root mean square error and the R. R alone a little bit in regression problem, because what you are working on is regression problem. So you need something more, because regression can be negative, it can be positive. It's a flow of how the data is changing with A is changing with B. So if A is increasing and B is reducing at the same rate, they will have high correlation, even though the values are different. They are in opposite direction. That's why we have negative and positive correlation. So you usually need another thing to support it. And one of what you can use to support your work is what you just asked for, and I'm going to show you how to see it there. That is the actual prediction. You can bring out your actual prediction and put it inside your paper. People can see how close they are to the value. Because sometimes root mean square error, MA, whatever is a relative term. If the values are big, the mistake when you add them together is going to be big. This is normal. It doesn't mean your work is not good. With a 96% R, I think that is acceptably very high. Then the root square error, MA, is a relative term. But if you can bring out the actual value that you have achieved and then put it side by side, people can visualize. And sometimes you can draw a scattergram graph to show how close they are to each other or how far away they are. So let me share the Wika environment and I can show you how you do that there. Let's say,
thank you, Doctor.
Yeah. So I hope we can, the Wika is showing now.
Yes.
Okay. Good. You see here, there are a lot of more options. You can see more options, things that you want to see. But there are many things you can do here, but these are not the only one you can see here. This is just showing you the basic result.
Okay.
If I want to see the actual prediction, I'll go to more options. You can see here. You can output model for training split. You can see, I want to see the actual values, output model for split. I want to see the actual value for the training. I want to see the entropy evaluation, whatever you want to see. Cost sensitive. So you have to check what information that you want to be there. And even you can play with evaluation metrics. You can see it gives you a lot of evaluation metrics. That's why you see a lot of output there. Or if you don't need some of them, you can just uncheck, I don't need this, and then you can come up with what you need.
Okay.
This is what to do. We got there through more options. Click more
Okay.
options, and then this is usually unchecked. It doesn't show
Okay.
the actual output. So if you do that, and then, yeah, you can see here, this is the output. This is for training set. Usually we don't get to do with training set. The screen will too much. But however, this is the one you need. This is the output prediction, the one for testing set. You have to shoot.
Okay.
How do you want to see the result? You want it to send it to a CSV file? You want to create an Excel similar file to get the result? Or you want to make it in a plain text?
Okay.
Yeah, so you can say, okay, give him in a plain text. So you can see here now, if you run the experiment once again, yeah. Can you see now that it has displayed the actual output? This was missing here before, if you take note.
Okay.
Can you see now?
Yes, I can see.
Yeah, this is classification. When you run the regression, you get the same thing. It's saying that this is the original value, this is the predicted value. Original value, predicted value. Some are correct, some are not correct. Are you with me now? So this is how you're going to see your output. So it's showing you the instance-based value that the classification output for the model. So,
okay.
Yeah. So this is where you have to uncheck, and then you can see your actual values. Then you can copy it and take it to Excel, plot stuff there, plot the two on the same plane, and then see how they are closer to each other. So I think that will also add to whatever information you have gotten, and pay attention to root mean square error. From my experience, root mean square error is always going to give you something reasonable, but the fact it's higher is a function of the value of, if you are dealing with data that is huge, and there are many mistakes, small mistakes, and the data is big, when you add them together, it's going to be more. So it's not a problem. So, but when you show them the actual values, either on a graph, put it in a table side by side, you can see the difference between the actual and the predicted value. Then this will be clearer to people that, yes, you have really achieved some improvement.
Thank you very much.
You can reach out later. If there's any clarification, you can also reach out privately for that guidance.
All right. Thank you very much.
I'm happy to also hear that. So you'll be able to follow the videos and you are able to start doing something in your area. This one we want for everybody. So we want as many people as possible to benefit from this kind of initiative. So please do share the news, spread it for people to also to be aware of it. And I wish you all the best. So I believe that's what we have for today. So thank you very much all for attendance, and hopefully we're going to get together next time. Have a nice day. Thank you. Bye.